Next question is, let a set S is equal to Z belongs to C such that mod of Z minus 2 is less than equals to 1 and Z into 1 plus I plus Z conjugate into 1 minus I is less than equals to 2. Let mod of Z minus 4I attains the minimum and maximum values respectively at Z1 belongs to S and Z2 belongs to S. If 5 into mod of Z1 square plus mod of Z2 square is equal to alpha plus beta into root 5, where alpha and beta are the integers, then the value of alpha plus beta is equal to. So this is a very interesting question. This is a question that comes from the complex number. Firstly, let us look at this part. What is mod of Z minus 4i? Here, this 4i can be written as 0, 4. So we have a point which is 0, 4. And it is given that it attains the minimum and maximum values at Z1 and Z2. So it is very clear that the point 0, 4 attains the minimum distance at Z1 and the maximum distance at Z2, right? Now, firstly, let us draw this set S, okay? It consists of two different equations, okay? First equation is mod of Z minus 2 less than equals to 1. This is representing an equation of circle, all right? Since it is an equation of circle, therefore, we have to get the radius, okay? And we will get it. Now let us focus on the second part. What is second part? Z into 1 plus I plus Z bar into 1 minus I is less than equals to 2. This is an equation of line. Means to draw the set, we have a circle and an equation of line. Okay. But now we do not know that where the line is to be made. Okay. So firstly, let us understand some basic things. This is a question that is from complex number. Okay, from complex number, we know that Z is equal to X plus IY. Okay, so we have two different equations. Let this be equation 1 and let this be equation 2. If we put Z is equal to X plus IY in equation number 1, then we will get an equation in a real form, right? And what will be the equation in a real form? It will be X minus 2 whole square plus Y square is less than equals to 1. When we put Z is equal to X plus IY in equation number 1, then we get an equation in a real form. And the equation is X minus 2 whole square plus Y square is less than equals to 1. Consider it as equation number 3rd. All right. Now, from here we can say that the center is 2, 0. What is center? It is minus G, minus F. Since it is the equation of circle, so center will be minus G, minus F. And from here we can say that the radius is 1 unit, right? So we have radius as 1 unit. Now, if we talk about the equation of line is the second equation. If we put Z is equal to X plus IY in the second equation, then also we get a real form, and its real form will be X minus Y is less than equals to 1. So we can write it as Y is greater than or equal to X plus 1. Okay. Let us consider this as equation number 4th. Okay. So we have substituted Z is equal to X plus IY in both the equations to get their real forms. So if we have Y is greater than or equal to X plus 1, it simply means that we want to make the equation of line Y is equal to X plus 1, and we have to take that part above the line. Above the line means above the x-axis. Okay. So now it is clear that where we have to form the line. Okay. So let us first draw the diagram. This is the x-axis and this is the y-axis. Consider this as the circle. Okay. We know the center of the circle. Let this be center of the circle, which is 2, 0. All right. We know that the line is to be made above the x-axis. Okay. So let us make it above the x-axis. Consider this as the line. Let us name this as A and B. All right. And according to the question, there will be a point which is P, and it will be joined with the center first. Okay. So when we join it with the center, it will be somehow this way. Now let us join it with point A and point B. So when we join it, you can see that it forms a tangent to the circle, right? PA and PB are the tangent to the circle. And whenever we form a tangent, it means that it forms an angle of 90 degrees. All right. So for both the equation, we have to take the common part. We have two different equations here. One is the equation of circle and one is the equation of the straight line. So what is the common part here? This is the common part, right? So we have to take this common part. And we know that the line is intersecting at y is equal to -1 and x is equal to 1. Okay, so this is the point y is equal to -1 and x is equal to 1. Okay, line will be intersecting here, right? This, if we extend this line, it will intersect at y is equal to -1 and this is x is equal to 1. All right. And the area above the line and the area inside the circle, which is the common area, is the shaded area. Now we want the maximum value of mode of z minus 4i. Okay, where z is the given region. And what is minus 4i here? Minus 4i means the distance of z from point 0, 4 when it is maximum and minimum. Means in simple words, we have to find the distance, which is the minimum distance and maximum distance from point 0, 4. Okay. So let us connect a point with a point on the circle, which is D. Let us name it as D. What is D here? When we connect this point P to D, then the point at which the line will intersect the circumference of circle, it is point D, right? So if we connect P to D, then we get that PD is the minimum distance, right? And PA is the maximum distance. Because here, the point at which the line is intersecting the circumference of the circle, it is point D. Okay. So now let us calculate PA. What is PA? PA will be distance from P to A. So for this, we have to use the distance formula. What is the distance formula? Distance formula is under root of x2 minus x1 square plus y2 minus y1 square. We need to find PA. It means we need point P and point A. What is point P? It is 0, 4. And what is point A? It is 1, 0, right? You can see that at point A, x is equal to 1 and y is equal to 0. So let us find it. Let us consider this values as x1, y1 and x2, y2. Okay. So it will be under root of 0 minus 1 square plus 4 minus 0 square. Okay. I hope it is clear to you. Then it will be equal to under root of 1 plus 16, which is equal to under root of 17. Now you can see that PA is a tangent. Okay. So PB is also a tangent here. So let us find the value for PB. Okay. So what will be P and B? PB will be again by using the distance formula under root of x2 minus x1 square plus y2 minus y1 square. What is P? P is 0, 4 and B is 2, 1. All right. We already know the point B, which is 2, 1. Now let us find PB. x2 minus x1 square, 0 minus 2 square plus y2 minus y1 square, 4 minus 1 square. So it will be under root of 4 plus 9, which is equal to under root of 13. All right. We have the value of PA and PB, which are the two tangents. But we want the coordinates of point D. Okay. So let us assume the angle theta. Okay. Let us assume the angle which is made by this point is theta, and we know that center is 2, 0. So if center is 2, 0 and angle is theta, so we can find the coordinates of point D in parametric form. Okay. So if we have center 2, 0 and angle is theta, right? So we can get the coordinates of D in parametric form. So what is the parametric form? It will be 2 plus r cos theta and 0 plus r sin theta. Okay, what is 2 and 0? It is the center. And r cos theta and r sin theta. We know that r is 1. What is the value of radius? It is 1. So it will be 2 plus cos theta and 0 plus sin theta. Okay. It is the coordinate of point D. Okay. So now we have the coordinates of point D. Now let us talk about PC. What is PC? PC is a line that is going from center to a y-axis. Okay, so let us calculate the slope for PC. And here we have to take tan theta, right? Because for slope, we always take tan theta, right? Now, how to calculate the slope? The basic formula for slope is y2 minus y1 upon x2 minus x1. We need to find the slope for PC, right? So what is P? P is 0, 4. And what is C? C is the center, that is 2, 0. So consider it as x1 and y1 and consider it as x2 and y2. So slope for PC will be y2 minus y1. What is y2? 0 minus y1 is 4. So 0 minus 4 divided by x2 minus x1. x2 is 2, x1 is 0. So 2 minus 0. So it will be minus 4 upon 2, which is equal to minus of 2. Okay, since this slope will be equal to tan theta, it means that tan theta will be equal to minus 2. You can see that tan theta is negative. What does it mean? If tan theta is negative, it means that theta is obtuse. Obtuse means it is more than 90 degree. Okay, so if tan theta is negative and theta is obtuse, therefore cos theta will be negative and sin theta will be positive. Okay, these are the basics that you should know, that if tan theta is negative and we have theta which is obtuse, means more than 90 degree. So cos theta will be negative and sin theta will be positive. All right. Now let us calculate the value for cos theta and sin theta. Okay, since we have tan theta, so we can easily find the values of cos theta and sin theta. Let us consider a right angle triangle. What is tan theta? Tan theta is equal to perpendicular upon base. It is equal to minus 2 upon 1. Okay, so perpendicular is minus 2 and base is 1. So what will be hypotenuse? It will be under root of minus 2 square plus 1 square, which is equal to under root of 5. We have used Pythagoras theorem here, which is h square is equal to p square plus p square. Hypotenuse square is equal to perpendicular square plus base square. All right. So we have the value of hypotenuse, which is root 5. Now cos theta. What is cos theta? It is base upon hypotenuse. What is base? 1. Hypotenuse is root 5. So cos theta is equal to 1 upon root 5. But according to the condition here, cos theta should be negative. So it will be minus 1 upon root 5. All right. Now if we talk about sin theta. Sin theta is perpendicular upon hypotenuse. What is the perpendicular? It is minus 2. What is the hypotenuse? It is root 5. But according to the condition, sin theta should be positive. So it will be plus 2 by root 5. Okay. So cos theta is minus 1 upon root 5 and sin theta is plus 2 upon root 5. Now we can find the coordinates of D. Okay. What are the coordinates of D? It is 2 plus cos theta and 0 plus sin theta. All right. What is cos theta? Minus 1 upon root 5. And what is sin theta? 2 upon root 5. So let us put this value. So coordinates of D will be 2 minus 1 upon root 5 and 2 upon root 5. Right. Now we know that PD was the minimum distance. Okay. And maximum distance was representing Z1. Right. So Z1 will be the complex form of point D. We know that point D is in the parametric form. And if PD is the minimum distance and maximum distance was represented by Z1, so Z1 will be the complex form of D. Okay. So what will be the complex form? We know that complex form is Z is equal to X plus IY. Okay. So for Z1, it will be 2 minus 1 upon root 5 plus I into 2 upon root 5. Okay, this is the value of X and this is the value of Y. So if we write it in the complex form, it will be X plus IY. All right. So this is the complex form of point D. Okay. Now we know that maximum distance was at PA. Okay. The maximum distance is at PA. It is very clear from the diagram also. You can see that PA is the maximum distance. Okay. So how we can represent the coordinate of A in complex form? We know that the coordinates of A here are 1, 0. Okay. So how can we represent this coordinates in the complex form? It will be 1 plus 0i because 1 is X and 0 is Y. And we know that complex form is X plus IY. So it will be 1 plus 0i. 1 plus 0i means 1. Okay. Therefore, we can say that z2 is equal to 1. And what is the value of z1? It is 2 minus 1 upon root 5 plus I into 2 upon root 5. Now, let us calculate mode of z2. Okay. What is z2? Z2 is 1. So, mode of z2 square will be also 1. Okay. Now, what is z1? Z1 value is 2 minus 1 upon root 5 plus I into 2 by root 5. So what will be mode of z1 square? It will be equal to 25 minus 4 root 5 divided by 5, right? Now, in the question, an expression is given to us. What is the expression? 5 into mode of z1 square plus mode of z2 square. Okay. So let us calculate its value. We have mode of z1 square and mode of z2 square. So 5 into mode of z1 square plus mode of z2 square. It will be 5 into, what is the mode of z1 square? It is 25 minus 4 root 5 divided by 5. All right. Plus, what is the mode of z2 square? It is 1. So when we simplify it, it will be 5 into 25 minus 4 root 5 plus 5 divided by 5. We have taken LCM here, right? So this 5 and 5 will be cancelled. So we have 25 plus 5 is 30 minus 4 root 5. So the value of 5 into mode of z1 square plus z2 square is 30 minus 4 root 5. But in the question it is given that its value is equal to alpha plus beta into root 5. Okay. So when we compare it with alpha plus beta into root 5, then we get the value of alpha is equal to 30 and the value of beta is equal to minus 4, right? Okay, because in the question it is given that 5 into mode of z1 square plus mode of z2 square is equal to what? Alpha plus beta into root 5. We have calculated 5 into mode of z1 square plus mode of z2 square. It is equal to 30 minus 4 root 5. Okay, it means that we have to compare this value. Okay, 30 minus 4 root 5 is equal to alpha plus beta root 5. So when we compare, alpha is equal to 30 and beta is equal to minus 4. What is beta here? It is the coefficient of root 5. And what is coefficient of root 5 here? It is minus 4. So it means that beta will be equals to minus 4. But we have to find alpha plus beta, right? So what will be alpha plus beta? It is 30 plus minus 4. The value of alpha is 30 and the value of beta is minus 4. So 30 plus minus 4 is 30 minus 4. Plus minus will be minus. 30 minus 4 is 26. So the value of alpha plus beta is 26. Therefore, for this question, the correct option is 26, right? This is the correct answer. I hope you are clear with this question. This question is a little bit lengthy, but it requires the basic concepts of complex number. You should know how to convert a parametric form into a complex form, and you should know that how we convert a form or equation into a real form. Okay, we just have to put z is equal to x plus iy, then it will be converted into its real form. I hope you are clear with this question. Next question is, let y is equal to y of x be the solution of the differential equation and x lies between 0 and pi by 2 with y of pi by 4 is equal to pi square by 32. If y of pi by 3 is equal to pi square by 18 into e power minus tan inverse alpha, then the value of 3 alpha square is equal to. In this given question, a differential equation is given. So let us write the differential equation first. dy by dx plus root 2y divided by 2 into cos power 4x minus cos 2x is equal to x into e power tan inverse of root 2 cot 2x, right? This is the differential equation. And we know that it is a linear differential equation. And we have to find the solution of this linear differential equation. So remember one thing, whenever we have to find the solution of a linear differential equation, firstly, we need to calculate the integrating factor. What is integrating factor? Integrating factor is denoted by IF. It is always equals to e power integral of p dx. Okay. So for this given equation, integrating factor will be e power integral of p. The value of p here is root 2 divided by 2 into cos power 4x minus cos 2x and dx. This root 2 is a constant, so it will go outside. So it is e power root 2 integral of 1 upon 2 cos power 4x minus cos 2x and dx. Okay, this integral is in the power. Now, we have to use a very short trick to solve this question. In the trigonometry, we know that there is a basic formula for 2 cos square x. 2 cos square x is equal to 1 plus cos 2x. But here we need the value for 2 cos power 4x. So let us square both the sides. Okay. So on squaring both the sides, we get 4 cos power 4x is equal to 1 plus cos 2x whole square. So from here cos power 4x will be equal to 1 plus cos 2x whole square divided by 4, right? So now we can substitute the value for cos power 4x. Also we can do one thing. We can apply the formula for a plus b whole square. What is the formula for a plus b whole square? A square plus b square plus 2ab. So cos power 4x will be equal to a square. A square means 1 square plus b square. What is b? B is cos 2x. So cos 2x square will be cos square 2x plus 2ab. 2 into 1 into cos 2x is 2 cos 2x divided by 4. Okay. So now we can substitute the value of cos power 4x in this given integrating factor. So it will be e power under root 2 into integral of 1 upon 2 into cos power 4x is 1 plus cos square 2x plus 2 cos 2x divided by 4. And then we have minus of cos 2x and dx. All right. So now we have to simplify it. This 2 and 4 will be cancelled. Now this 2 will be divided with each and every term. Okay. So it will be e power root 2 into integral of 1 upon 1 by 2 plus cos square 2x by 2 plus 2 cos 2x by 2 and minus cos 2x. So this 2 and 2 will be cancelled. Cos 2x minus cos 2x is 0. All right. So the remaining terms are e power root 2 into integral of 1 upon 1 by 2 plus cos square 2x by 2 and dx. Okay. Now, what we have to do is we have to again simplify this terms. Okay. We have 1 by 2 plus cos square 2x by 2. Okay, so we can take this 2 on the numerator. So it will be e power root 2 into integral of 2 upon 1 plus cos square 2x and dx. Okay, now if we divide on both the parts, which is upper part and the lower part, that is, if we divide on the numerator and denominator, it will be equals to e power root 2, okay, into integral of sec square 2x divided by 1 plus sec square 2x and dx, and 2 will be a constant, so it will be outside, so it will be root 2 into 2. All right. Now we know that there is an identity which is sec square 2x is equals to 1 plus tan square 2x. It is coming from sec square theta is equal to 1 plus tan square theta, right? So in the place of sec square 2x, we can write 1 plus tan square 2x, right? So it will be e power 2 root 2 into integral of sec square 2x upon 1 plus, in this sec square 2x, we have to put the value of 1 plus tan square 2x. So it will be 1 plus tan square 2x and dx. Okay. So 1 plus 1 will be 2. So this will be e power 2 root 2 into integral of sec square 2x divided by 2 plus tan square 2x and dx. This is the simplified form. Now it is very simple. We just have to solve this integral part. So we have to put tan 2x is equals to t. Now we have to differentiate both the sides. D by dx of tan 2x will be sec square 2x and d by dx of 2x will be 2. So multiplied by 2. It is equals to dt upon dx, right? So 2 sec square 2x dx will be equals to dt. Okay, so we have the value for 2 sec square 2x dx. Now we can take this particular 2 inside the integral. So it will be e power root 2 into 2 sec square 2x dx divided by 2 plus tan square 2x. Okay, so it will be equals to e power root 2 into integral of. We know that 2 sec square 2x dx is equal to dt divided by. In the denominator, we have 2 plus tan square 2x. Okay, but tan 2x is t. So tan square 2x will be t square. So it will be t square. All right. So now we have to again find the value of this integral. It can be written as e power root 2 into integral of dt upon 2 can be written as root 2 square plus t square. Okay. Now why we have written 2 as a root 2 square? Just to make this integral in the form of dx upon x square plus a square. Okay. So what is the formula for integral of dx upon x square plus a square? This is equals to 1 upon a into tan inverse x upon a plus c. Okay, so this is the formula that we have to use here. So it will be e power root 2, okay, into 1 upon a. What is a? It is 2, okay. So it will be root 2. Here a is root 2 and x is t, okay. So it will be equals to 1 upon root 2, right? We are taking it outside since it is a constant. All right. So we have taken it outside. And remember that the formula for integral of dx upon x square plus a square is 1 upon a tan inverse x upon a plus c. All right. So now we have to use this formula. So e power root 2 is outside. Now integral of dt upon root 2 square plus t square. It is 1 upon a means 1 upon root 2, right? And tan inverse of x upon a. What is x? X is t square. What is the value of t square? T square is tan 2x divided by a. A is again root 2, right? So this will be e power root 2 upon root 2 into tan inverse of tan 2x divided by root 2, right? This root 2 and root 2 will be cancelled, okay? So it will be equals to e power tan inverse tan 2x upon root 2, right? Now, we have to just look at this power part, okay? And in the question, equation is given to us, okay? So firstly, let us write that equation. See, whenever we have to find the integrating factor, then after finding it, we have the value. This is the value of integrating factor. Now what we have to do is, we have to do one thing, that is y into integrating factor is equal to integration of q into integrating factor dx plus c. All right. So it will be y into integrating factor. Okay. What is integrating factor here? Can you tell me? It is e power tan inverse tan 2x upon root 2. Okay. We have just calculated it. It is equals to integral of x into e power tan inverse root 2 cot 2x into e power tan inverse tan 2x upon root 2 dx plus c. All right. What does this equation mean? It is y into integrating factor is equals to integration of q into integrating factor and dx plus c. Okay. Now, listen very carefully. Here, we have two powers of e. All right. So, focus on these two parts. Here, the second part is tan inverse tan 2x upon root 2. Okay. This part can be written in some other ways. Okay. We can write this as cot inverse root 2 cot 2x. Why? Because we know that tan inverse x is equal to 1 by cot inverse x. Okay, so tan inverse x is equal to 1 by cot inverse x. So it can be written as y into e power tan inverse tan 2x upon root 2. Okay, this will be equals to integral of x into e power tan inverse root 2 cot 2x into e power. Now this value can be written as cot inverse root 2 cot 2x and dx plus c, right? Now, since the base is same, so power will be added. So it will be equals to integral of x into e power tan inverse root 2 cot 2x plus cot inverse root 2 cot 2x. Okay. Now we have to use a formula here. And the formula is tan inverse x plus cot inverse x. It is always equals to pi by 2. It means that tan inverse root 2 cot 2x plus cot inverse root 2 cot 2x will be equals to pi by 2. So the value will be integral of x into e power pi by 2 and dx plus c. Okay, and the left hand side is y into e power tan inverse tan 2x upon root 2. All right. So now you can see that this whole term is changed to pi by 2 because of tan inverse x plus cot inverse x is equal to pi by 2. Okay. So now the integral part is x into e power pi by 2 dx plus c. All right. Now what we have to do is we have to find the integral part. Okay. Here e power pi by 2 is a constant. So it will be outside. Integral of x dx will be x square by 2. We know that integral of x power n is equal to x power n plus 1 upon n plus 1. Okay, that is why integral of x power 1 will be x square upon 2 n plus c. C is a constant. Okay, and the left hand side will be as it is, which is y into e power tan inverse of tan 2x upon root 2. Okay, so this is the required value. Okay, now what we have to do is we have to focus on the question. In the question, two different conditions are given here. Okay, y is equal to y of x and y of pi by 4 is equal to pi square by 32. So let us understand it first. Okay, it is given that y is equal to y of x. Okay, and a condition is given here in the question, that is y of pi by 4 is equals to pi square by 32. When we compare both these values, then we get x is equal to pi by 4 and y is equal to pi square by 32. It simply implies that when x is equal to pi by 4, then y is equals to pi square by 32. So when we put these values here, we get the value of constant, which is c is equal to 0. Similarly, one more value is given in the question, which is y of pi by 3 is equals to pi square by 18 into e power minus of tan inverse alpha. Okay. It is also in the same form, which is y is equal to y of x. So this is y of x. It means that when x is equal to pi by 3, then y is equal to pi square by 18 into e power minus of tan inverse alpha, right? So we have to substitute these values of x and y. Okay. So let us substitute the values of x and y. We have to substitute the values of x and y here. So let us consider this as equation number 1. On putting the values of x and y, firstly the left hand side will be y into, what is the value of y? Pi square by 18 into e power minus of tan inverse alpha into, again, e power tan inverse of tan 2x upon root 2. This is the left hand side. This will be equals to e power pi by 2 into x square. What is the value of x? X is pi by 3. Okay. So pi by 3 square means pi square by 9. Okay. So pi square by 9 divided by 2. So it will be pi square by 18. Okay. And plus c. So this is the right hand side. We have substituted the value of x and y. The value of x is pi by 3 and the value of y is pi square by 18 into e power minus of tan inverse alpha. Okay, we have substituted both these values in equation 1. So this is the required expression. Okay, now focus on this part. Okay, e power minus of tan inverse alpha into e power tan inverse of tan 2x upon root 2. Okay, here also we have to substitute the value of x. Okay, so it will be pi square upon 18 into e power minus of tan inverse of alpha into e power of tan inverse of tan 2 into x. What is x? X is pi by 3 divided by root 2. Now what is tan 2 into pi by 3? Let us understand this concept. Okay. Tan 2 into pi by 3 means tan 2 into 180 upon 3. It means tan, this will be cancelled, tan 120 degree. Do you know the value of tan 120? No, right? But tan 120 can be written as tan 180 minus 60. And we know the concept for tan 180 minus theta. It is always equals to minus of tan theta. It means that tan 180 minus 60 will be equals to tan of 60, but it will be negative. Now, what is tan of 60? It is root 3 by 2. But minus of tan of 60 will be minus root 3 by 2. So, the expression here will be equals to minus of root 3 by 2. Okay, now let us write it again. We have left hand side as pi square upon 18 into e power minus of tan inverse alpha into e power tan inverse. Now we have the value of tan 2 pi by 3. What is the value? It is minus of root 3 by 2. Okay. This is the value. And this is the left hand side. Now this will be equal to right hand side. What is the right hand side? Right hand side is e power pi by 2 into pi square by 18 plus c. All right. Now, if we look carefully, pi square by 18 and pi square by 18 will be cancelled, right? So let us write the remaining terms. What are the remaining terms? E power minus of tan inverse alpha into e power tan inverse minus of root 3 by 2 is equals to e power pi by 2 plus c. All right. So now let us convert this value. Okay. Since this power is in tan inverse. Okay. So you can see that base is same. It means that the powers will be added. So we have to compare the powers of E on both the sides. So here on the left hand side, it will be minus of tan inverse of alpha plus tan inverse of root 3 by 2 will be equals to pi by 2. We have compared the powers on both the sides. Okay. So here on the left hand side, it can be written as tan inverse of minus alpha, right? This negative sign can go before alpha. Now, let us do one thing. Let us transfer this tan inverse root 3 by 2 to the right hand side. So it will be pi by 2 minus tan inverse root 3 by 2. Do you know what is pi by 2 minus tan inverse x? Pi by 2 minus tan inverse x is equal to cot inverse x. So tan inverse alpha minus alpha. Okay, it is minus alpha. It will be equals to pi by 2 minus tan inverse root 3 by 2. See, this is in the form of pi by 2 minus tan inverse x. It will be cot inverse x. It means that cot inverse under root of 3 by 2. Okay, now what is cot inverse under root of 3 by 2? It can be written as tan inverse under root of 2 by 3. Because we know that there is a formula cot inverse x is equal to 1 upon tan inverse x, right? So cot inverse root 3 by 2 will be equals to tan inverse root 2 by 3. It will be reciprocal, right? So we have tan inverse alpha is equals to tan inverse under root of 2 by 3. Okay. See, now this tan inverse and tan inverse will be cancelled. So directly we can write alpha is equals to under root of 2 by 3, right? Now on squaring both the sides, we have alpha square is equal to 2 by 3. Now cross multiplying, 3 alpha square will be equal to 2. And this is the required value that we have to calculate for this equation. We have to calculate the value for 3 alpha square, and the value of 3 alpha square is 2. So for this question, we can say that the correct answer is 2. I hope you are clear with this question. It is a little bit lengthy question, but it requires the basic concepts related to trigonometry. Next question is, let D be the distance between the foot of perpendiculars of the point P 1, 2 and minus 1 and point Q 2, minus 1 and 3 on the plane minus x plus y plus z is equal to 1. Then D square is equal to. So for this given question, it is given that D is the distance between the foot of the perpendiculars. All right. And to find the distance between the foot of the perpendiculars, first we need to calculate the foot of the perpendiculars from point P and then from point Q. Okay. So the basic concept for this question is, we know that foot of perpendicular from a point, let us say the point is x1, y1 and z1. Okay. On the plane ax plus by plus cz is equal to d is always given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. It is equals to minus of ax1 plus by1 plus cz1 minus d whole divided by a square plus b square plus c square. All right. So this is the basic concept that we have to use for this question. Now coming to the solution part. In this question, two different points are given. So firstly, let us calculate the foot of the perpendiculars from both these points. Okay. So foot of perpendicular from point P. What is point P? It is 1, 2 and minus 1. So we know that foot of perpendicular from a point is considered as x1, y1 and z1. So let this be equal to x1, let this be equal to y1 and let this be equal to z1. Okay. And we know that this is given on the plane. So what is the plane that is given in the question? It is minus x plus y plus z is equal to 1. All right. So the plane is minus x plus y plus z is equal to 1. When we compare this equation of plane with the standard equation of plane, that is ax plus by plus cz is equal to d, we get the values for a, b, c and d. Am I right? Yes. Because what is a? A is the coefficient of x, b is the coefficient of y, c is the coefficient of z. All right. What is coefficient? Coefficient is the constant or any number that is with the variable. Okay. So on comparing both these equations, see, consider this as equation 1 and consider this as equation 2. On comparing equation 1 and 2, we get a is equal to minus 1. See, a is the coefficient of x here. So in this equation, what is the coefficient of x? It is minus 1. All right. Then what is the coefficient of y? It is 1. So b will be equal to 1. As we know that b is the coefficient of y. Similarly, c will be equals to 1. And on the right hand side, you can see that there is d. So comparing this equation, on the right hand side, we have 1. So the value of d will be 1. All right. Now we have all the values. We just have to put these values in the given formula, which is x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c is equal to minus of ax1 plus by1 plus cz1 minus d divided by a square plus b square plus c square. All right. So we are calculating the foot of perpendicular from point P. So we have to consider x1 as 1, y1 as 2 and z1 as minus 1. Okay. So substituting this value, what will be x minus x1? X minus, the value of x1 is 1 divided by a, the value of a is minus 1. This is equal to y minus y1. Y minus y1. What is y1? Y1 is 2 divided by b. So b is 1. It is equal to z minus z1. What is the value of z? Z is the value of Z only, okay? And Z minus Z1. What is the value of Z1? Z1 is minus 1. Divided by C. The value of C is 1. It is equal to minus of AX1. AX1 means A into X1, okay? So what is A? A is minus 1 into X1 is 1. Plus by1 means b into y1. The value of b is 1 and y1 is 2. Plus cz1. C is 1 and z1 is minus 1. Minus of d. D is 1. And whole divided by a square plus b square plus c square. So what is a? A is minus 1. So minus 1 square plus b square. B square will be 1 square and c square will be also 1 square. Okay. What we have done is we have substituted all the values in the given formula. Okay, so now we have to further simplify this. So it will be equals to x minus 1 divided by minus 1 is equal to y minus 2 divided by 1 is equal to z plus 1 divided by 1. This minus and minus will be plus here. Now this will be equals to minus of. Minus 1 into 1 is minus 1. Plus 1 into 2 is 2. Plus 1 into minus 1 will be minus 1. And at last there is minus 1. Divided by minus 1 square is 1. Plus 1 square is 1. Again 1 square is 1. Alright. So it will be x minus 1 upon minus 1 is equal to y minus 2 upon 1 is equal to z plus 1 upon 1 is equals to minus of minus 1 minus 1 and minus 1 will be minus 3. Minus 3 plus 2 is minus 1. All right. Divided by 1 plus 1 plus 1. It is 3. So this will be equals to 1 by 3 because minus minus will be plus. Okay. Now we know that all these three terms are equal to 1 by 3. Okay. So separately equating all the terms, we can get the value of x, y, and z. So firstly equating the first term, that is x minus 1 divided by minus 1 is equal to 1 by 3. Now we have to cross multiply. Cross multiply means x minus 1 multiplied by 3 will be equal to minus 1 into 1. So now let us simplify this value. 3 into x will be 3x. Then 3 into minus 1 will be minus 3. It is equal to minus 1 into 1. It is minus 1. Okay. So 3x will be equal to minus 1 plus 3. When this 3 will go to the right hand side, it will be positive. So 3x will be equals to 2. Minus 1 plus 3 is 2. So x will be equal to 2 by 3. Similarly, we can calculate the value of y and z. So for the second part, y minus 2 divided by 1 will be equal to 1 by 3. Again cross multiplying, we get y minus 2 into 3 is equal to 1 into 1. Okay. So 3 into y is 3y minus 3 into 2 is 6. It is equal to 1. So 3y is equal to 1 plus 6. So 3y will be equal to 7, right? So y will be equals to 7 by 3. Similarly, we can calculate the value for z. The last part is z plus 1 divided by 1. It is equal to 1 by 3. Again cross multiplying. Z plus 1 into 3 is equal to 1 into 1. All right. 3 into z is 3z plus 3 into 1 is 3. It is equal to 1. So 3z will be equals to 1 minus 3. Okay. This 3 is positive here. So when it will go to the right hand side, it will be negative. So 3z will be equals to minus 2. So z will be equals to minus 2 by 3. So here we have the coordinates of the foot of the perpendicular for point P. So we have P dash as 2 by 3, 7 by 3 and minus 2 by 3. This is the value for x, y and z for the foot of perpendicular from point P. Okay. Similarly, we have to calculate the foot of perpendicular from point Q. So let us see what is point Q. Point Q is 2 minus 1 and 3. All right. 2 minus 1 and 3. So now we will consider this as x1, this as y1 and this as z1. And the equation of plane that is given in the question is minus x plus y plus z is equal to 1. When we compare it with the equation ax plus by plus cz is equal to d, this is the standard equation of plane. All right. So we get the value of a, b, c and d. A is the coefficient of x. What is the coefficient of x here? Minus 1. B is 1, C is 1 and D is also 1. We have already calculated these values, right? So now let us calculate the foot of perpendicular from point Q. We have to use the same formula, x minus x1 upon a. So x minus, what is x1? x1 is 2. We are considering this points. Upon a, the value of a is minus 1. All right. It is equal to y minus y1. So y minus, what is the value of y1? y1 is minus 1 divided by b. The value of b is 1. It is equal to z minus z1. So what is the value of z1? It is 3 divided by c. C is 1. It is equals to minus of ax1. Ax1 means a into x1, right? What is a? Minus 1. Minus 1 into 2, because x1 is 2, plus b into y1. B is 1 and y1 is minus 1, plus cz1. C is 1 and z1 is 3. Minus d. D is 1 divided by a square plus b square plus c square. Value of a is minus 1. So a square will be minus 1 square, then b square, and then c square. Okay, the value of b is 1 and the value of c is also 1. We have simply substituted the values here in the given formula for point Q. This is the basic formula. All right. Now we have to simplify this value. So it will be x minus 2 divided by minus 1 is equal to y minus minus will be plus 1 divided by 1 is equal to z minus 3 divided by 1. Okay. So it will be equals to minus of minus 1 into 2 is minus 2. Then 1 into minus 1 is minus 1. Then 1 into 3 is plus 3. And at last there is minus 1. This will be divided by minus 1 square is 1 plus 1 square is 1. Again 1 square is 1. All right. So we have x minus 2 divided by minus 1 is equal to y plus 1 divided by 1 is equal to z minus 3 divided by 1 is equals to minus of minus 2 minus 1 is minus 3. Minus 3 plus 3 is 0. So it will be minus 1 divided by 1 plus 1 plus 1. It is 3. All right. So this will be equal to 1 by 3. Now we have to separately equate all the terms. So equating first term. What is the first term here? X minus 2 upon minus 1. It is equal to 1 by 3. All right. So on cross multiplying, we have x minus 2 into 3 is equal to minus 1 into 1. So x into 3 is 3x minus 2 into 3 is minus 6. It is equal to minus 1. 3x will be equal to minus 1 plus 6. And 3x will be equal to 5. So x will be equal to 5 by 3. Similarly, equating the second term. Second term is y plus 1 divided by 1 is equal to 1 by 3. Again, cross multiplying, it will be y plus 1 into 3 is equal to 1 into 1. So 3 into y is 3y plus 3 into 1 is 3. It is equal to 1 into 1. That is 1. 3y will be equal to 1 minus 3, right? When this 3 will go to the right hand side, it will be negative. So 3y will be equals to minus 2 and y will be equals to minus 2 by 3. Now similarly, we have to equate the last term. What is the last term here? It is z minus 3 divided by 1. It is equal to 1 by 3. Again, cross multiplying these values. Z minus 3 into 3 is equal to 1 into 1. Okay. So 3 into z is 3z. Minus 3 into 3 is 9. It will be equal to 1. So 3z will be equals to 1 plus 9. When this 9 will shift to right hand side, it will be positive. So 3z will be equals to 10. All right. Z will be equals to 10 by 3. Now we have the coordinates of x, y, and z, which are the foot of perpendicular from point Q. Okay. So consider them as Q dash. So what are the points for Q dash? 5 by 3, minus 2 by 3, and 10 by 3. All right. Now we have P dash and we have Q dash, right? We have to calculate the distance between both these points. What are the points P dash and Q dash? So let us write P dash first. What is the values of P dash? 2 by 3, 7 by 3, and minus 2 by 3. So P dash is 2 by 3, 7 by 3, and minus 2 by 3. All right. So now what we have to do is we have to just find the distance between both these perpendiculars. Okay. So P dash Q dash will be equals to under root of. Okay. So now what we have to do is we have to do the sum of squares of the values. That is 1 square plus 3 square plus 4 square. All right. So what is 1 square? It is 1. 3 square is 9. 4 square is 16. So it will be equals to 1 plus 9 is 10. 10 plus 16 is 26. Okay. So this is the value of P dash Q dash, or this is the value of distance between both the foot of perpendiculars. Okay. And we know that what is distance between both the foot of perpendiculars? It is D. It is already mentioned in the question. You can see that it is given here that D is the distance between the foot of perpendiculars of the point P and Q. Okay. So we have the value of D. What is the value of D? Here D is under root of 26, but we have to calculate D square. Okay. So if D is under root of 26, then D square will be under root of 26 into under root of 26. So it will be equals to 26. Okay. Whenever we multiply any same number which are in the under root, then it gives the number itself. For example, root 2 into root 2 gives 2. Root 3 into root 3 gives 3. Okay. So similarly, root 26 into root 26 will give 26. So the value of D square is equal to 26. Hence, the correct answer for this question is 26. I hope you are clear with this question, right? The main and the basic concept that you have to remember is the concept for the foot of perpendicular from a point on a given plane. Next question is the number of elements in the set S is equal to theta, where theta belongs to minus 4 pi to plus 4 pi, such that 3 cos square 2 theta plus 6 cos 2 theta minus 10 cos square theta plus 5 is equal to 0 is. So here a set is given which is S, and the range of theta is given that theta lies between minus 4 pi to plus 4 pi. Okay, so we have to find the number of elements in the given set. So firstly, let us simplify the given trigonometric expression, which is 3 cos square 2 theta plus 6 cos 2 theta minus 10 cos square theta plus 5 is equal to 0. Okay. So it will be 3 cos square 2 theta plus 6 cos 2 theta. Then if we take 5 common from this term, third term is 10 cos square theta. So if we take 5 common, what will be the remaining terms? 2 cos square theta and plus 5 is equal to 0, right? Because 5 into 2 is 10. All right. Now we have to use a formula which is 2 cos square theta is equals to 1 plus cos 2 theta. Okay. So we have to substitute the value of 2 cos square theta here. Okay. So it will be 3 cos square 2 theta plus 6 cos 2 theta minus 5 into 1 plus cos 2 theta plus 5. Okay, this is the value for 2 cos square theta. You have to remember this basic formula. You can see that the whole expression is in the form of cos 2 theta. Okay, so now this will be equals to 3 cos square 2 theta plus 6 cos 2 theta. When we multiply this with the brackets, it will be minus 5 minus 5 cos 2 theta. Okay. Minus 5 into 1 is minus 5, and minus 5 into cos 2 theta is minus 5 cos 2 theta, and plus 5 is equal to 0. All right. So now 3 cos square 2 theta. Then 6 cos 2 theta minus 5 cos 2 theta. It means that from 6 cos 2 theta, if we subtract 5 cos 2 theta, then we have only 1 cos 2 theta, and minus 5 and plus 5 will be 0. Okay, so this will be equals to 0. Now, if we take cos 2 theta common, you can see that in both the terms, cos 2 theta is common. So taking cos 2 theta common, the remaining terms will be 3 cos 2 theta plus 1. It is equal to 0. Okay, so in this case, two terms will be equal to 0. Okay, firstly, this term will be equal to 0, which is cos 2 theta will be equal to 0. And secondly, 3 cos 2 theta plus 1 will be equal to 0. So when 3 cos 2 theta plus 1 is 0, then 3 cos 2 theta will be equal to minus 1, or cos 2 theta will be equals to minus 1 by 3. So we have two values for cos 2 theta. First value is 0 and second value is minus 1 by 3. Okay. Now let us focus on the question. In the question, it is given that theta belongs to minus 4 pi and plus 4 pi. Okay. So theta belongs to minus 4 pi and plus 4 pi. But we have cos 2 theta, right? So if theta will belongs to minus 4 pi and plus 4 pi, then what will be the range of 2 theta? See, you can see that here cos 2 theta is equal to 0. So we just have to imagine the condition in which cos 2 theta will be equal to 0. So cos 2 theta will be equal to 0 when this 2 theta will be a odd multiple of pi by 2. Okay. So it means that 2 theta should be equal to 2n plus minus 1 into pi by 2. This is the basic formula when 2 theta will be a odd multiple of pi by 2. Okay. Now we have to substitute the values here. Okay, if 2 theta is equal to 2n plus minus 1 into pi by 2, then theta will be equals to 2n plus minus 1 into pi by 4. Okay, this 2 will be gone to the right hand side and it will be multiplied, okay, in the denominator. So 2 into 2 will be 4, right? So now here we have to put the values of n. Okay, so when n will be equal to 1, 2, 3 and 4, then we get values plus minus pi by 4. Okay. Then plus minus 3 pi by 4. Then plus minus 5 pi by 4. Then plus minus 7 pi by 4. Then plus minus 9 pi by 4. Okay. Then plus minus 11 pi by 4. And plus minus 13 pi by 4 and plus minus 15 pi by 4. Okay. So we have to take the limits up to plus minus 15 pi by 4 because it is given that theta lies between minus 4 pi and plus 4 pi. If we go to the next odd term, which is 17 pi by 4, then it will exceed the value of 4 pi. Okay. What is 4 pi? 4 pi means 4 into pi. What is the value of pi? The value of pi is 180. Okay. So it means that 4 pi is equals to 180 into pi, right? So 180 into 4 is 720. Okay. And the last limit here is 15 pi by 4. So what is 15 pi by 4? It is 15 into 180 by 4. So this will be cancelled. Again, it will be cancelled with the table of 2. Now, 15 into 45. Okay, what is 15 into 45? It is 675. Okay, you can see that 675 is below 720. So, this is the last term that we have to take according to the range of theta here. Okay, and I hope these values are clear to you. For example, here in this place, if we put n is equal to 0, so it will be 2 into 0 plus minus 1 into pi by 4. So 2 into 0 will be 0 and 1 into pi by 4 will be pi by 4, and since there is plus minus, so it will be plus minus pi by 4. Similarly, when we keep n is equal to 1, 2, 3 and so on, we get all these values for theta. All right. So these are the values for theta. Okay. So I hope this concept is clear to you. Now, let us focus on all these values of theta. You can see that the first part, which is cos 2 theta is equal to 0. For this part, how many total values we have? 1, 2, 3, 4, 5, 6, 7 and 8. Okay. But this is the value of theta. So if theta have 8 values, then 2 theta will have 8 into 2 values. That is 16 values, right? Or 16 elements. Now this is for the first part. Similarly, for the second part, which is cos 2 theta will be minus 1 by 3. So for cos 2 theta is equal to minus 1 by 3, there will be 16 more elements similarly, right? Which are the odd multiples of pi by 2. So here, total elements in both the cases are 16 plus 16, that is 32. Okay, I hope this condition is clear to you. You can see that for the first condition, for cos 2 theta is equal to 0. Okay, so cos 2 theta will be 0 when theta will be equals to all these given values, and the total values are 8. Okay, but we have to multiply it with 2 because we are talking about 2 theta. Okay, so 8 into 2 is 16. So for the first part, we have 16 elements. Similarly, for the second part is cos 2 theta is equal to minus 1 by 3. So for second part also, we have same 16 more. elements. Okay, so the total elements will be 16 plus 16, that is 32. So for this question, the correct answer is 32. I hope you are clear with this question. Next question is the number of solutions of the equation 2 theta minus cos square theta plus under root 2 is equal to 0 in R is equal to. So for this question, we have to find the total number of solutions for the given equation. So let us write the given equation first. The given equation is 2 theta minus cos square theta plus under root 2 is equal to 0. This equation can be also written as 2 theta plus root 2 is equal to cos square theta, right? When this cos square theta will go to the right hand side, it will be positive. Now, let y is equal to 2 theta plus root 2 is equal to cos square theta. So, we will have two different values of y here. Okay, we have assumed this value equal to a variable which is y. So, y will be equals to 2 theta plus under root 2 and y will be equals to cos square theta. Am I right? Because both these terms are equal, so y will be also equal to both of them. Okay. Now, there is a very short trick to identify the number of solutions for this kind of equations. Do you know what is the short trick here? The short trick is number of intersecting points will be equal to number of solutions of the equation. For the equation, we have two different values of y, right? So for both this value, we need to make a graph. A graph will be made, okay? And we have to represent this value in the form of a graph. And the number of intersecting points for both the curve will be equal to number of solution for the equation. This is the short trick that we have to use here, okay? So first, let us make the graph for both these values, okay? First value is y is equal to cos square theta. Do you know where cos square theta lies in the graph? The value of cos square theta always lies above the x-axis. This is a very basic concept. You need to remember this. All right. So let us make coordinate axis first. Okay. This is x-axis and this is y-axis. We know that y is equal to cos square theta. This value will be always above the x-axis. So let us make the curve for y is equal to cos square theta, right? So consider this as the curve for y is equal to cos square theta. Okay. We have made curve for one value of y. Another value of y is equal to 2 theta plus root 2. We can see that this is in the form of equation of a straight line. It means that here for y is equal to 2 theta plus root 2, a straight line will be formed. All right. So let us make a straight line here. So straight line will be somehow in this way. All right. This will be the straight line. Okay. So you can see that this is the straight line for y is equal to 2 theta plus under root of 2. And this is the curve for y is equal to cos square theta. Now the trick here is number of intersecting points will be equal to the number of solution of equation. So we have to calculate number of intersecting points. Okay. So for the straight line and for the curve, can you tell me what are the number of intersecting points here? We can see that this is the curve and this is the straight line, and both this are intersecting only at a single point. Okay, this is the single point at which both straight line and the curve intersect each other. All right, so this will be equal to the number of solutions for this equation. Okay, so we can say that both the graphs intersect at one point. Okay, So it means that intersecting points are only one. There is only a single intersecting point for both these graphs. So the number of solutions for this equation will be also 1, because the short trick is number of intersecting points will be equal to the number of solutions of the equation. And we know that number of intersecting point for this particular graph is 1. So number of solutions will be also 1. Therefore, for this question, the correct answer is 1. I hope you are clear with this question. The main trick here is you just have to identify the number of intersecting points, because that will be equal to the number of solutions. All right. So I hope you are clear with this question. Next question is 50 tan into 3 tan inverse 1 by 2 plus 2 cos inverse 1 by root 5 plus 4 root 2 tan into 1 by 2 tan inverse 2 root 2 is equal to. We have to find the value for this given expression, right? So let us first write the given expression. 50 tan into 3 tan inverse 1 by 2 plus 2 cos inverse 1 by root 5 plus 4 root 2 tan into 1 by 2 tan inverse 2 root 2. All right. So let us simplify this expression first. 50 tan. Now you can see that here there is 3 tan inverse 1 by 2. So we can write 3 tan inverse 1 by 2 as tan inverse 1 by 2 plus 2 tan inverse 1 by 2. Am I right? 3 can be written as 1 plus 2. So 3 tan inverse 1 by 2 can be written as tan inverse 1 by 2 plus 2 tan inverse 1 by 2. And we have plus 2 cos inverse 1 upon root 5. All right. So this term here is in the form of cos inverse. And you can see that except this term, all the other terms are in the trigonometric form of tan. Okay. So we have to convert this into tan. Now how we will convert it? Consider a right angle triangle here. All right. Let this be a right angled triangle. Okay. It is given that cos inverse 1 by root 5. We know that cos theta is equals to base upon hypotenuse. Okay. So this will be 1 and this will be root 5. 1 is the base and root 5 is the hypotenuse. So by Pythagoras theorem, perpendicular will be root 4, and we know that root 4 is equal to 2. Now we have to convert it into tan inverse. Okay. So we know that tan theta is always equals to perpendicular upon base. Okay. So here the perpendicular is 2 and the base is 1. Okay. So we can say that cos inverse 1 upon root 5 will be equal to tan inverse 2 by 1. And tan inverse 2 by 1 is tan inverse 2. All right. So in the place of cos inverse 1 by root 5, we can write tan inverse 2. All right. So it will be 50 tan into tan inverse 1 by 2 plus 2 tan inverse 1 by 2 plus 2, then cos inverse 1 by root 5. It will be equals to tan inverse 2. All right. Then we have the remaining term plus 4 root 2 into tan into tan inverse of 2 root 2. Okay, and here there is 1 by 2. So this is the remaining expression here. All right. So now you can see in this part, from last two terms, 2 is common. Okay. So let us take 2 common. So it will be 50 tan inverse 1 by 2 will be as it is. Then we take 2 common from the second and third term. So when we take 2 common, the remaining terms are tan inverse 1 by 2 plus tan inverse 2. Okay. And the remaining terms are 4 root 2 tan into 1 by 2 tan inverse 2 root 2. Now you have to listen very carefully, because to further solve this expression, firstly we need to understand 2 basic formulas. Okay. The first formula that we have to use here is the formula for tan inverse x plus tan inverse y. It is equals to tan inverse x plus y divided by 1 minus xy. All right. And the second formula that we have to use for this question is 2 tan inverse x. Do you know what is the formula for 2 tan inverse x? It is equals to tan inverse 2x upon 1 minus x square. All right. So these are the two basic formulas that we have to use here. Okay. So firstly, you can see that this particular form is in the same form as tan inverse x plus tan inverse y. Here x is 1 by 2 and y is 2. Okay. So let us first apply the formula in this particular part. Okay. So it will be 50 tan into tan inverse 1 by 2 plus 2 into, now we have to apply the formula for tan inverse x plus tan inverse y. Remember that x is equal to 1 by 2 and y is equal to 2. So what is the formula? Formula is tan inverse x plus y. What is x? 1 by 2 plus y. Value of y is 2. Divided by 1 minus x into y. What is x? 1 by 2 into y. Y is 2. All right. So then we have 4 root 2 tan into 1 by 2 tan inverse 2 root 2. Now, when we solve this particular expression, it will be 50 tan into tan inverse 1 by 2 plus 2 into tan inverse. Okay. In the numerator part, we will have 1 plus 4 by 2. And in the denominator, this 2 and 2 will be cancelled. So 1 minus 1 will be 0. You can see that this expression will have the infinite value. Okay. And we know that the infinite value of 10 is always equals to pi by 2. Okay. So remember this. Infinite value of 10 is always equals to pi by 2. So this particular term will be equal to pi by 2. And what are the remaining terms? The remaining terms are 4 root 2 tan into 1 by 2 tan inverse 2 root 2. All right. So this becomes 50 tan into tan inverse 1 by 2 plus 2 into, we know that this value will be equals to pi by 2. All right. Plus 4 root 2 into tan into 1 by 2 tan inverse 2 root 2. All right. Now, talking about the last part. What is the last part? Last part is, let us write it again. 50 tan into tan inverse 1 by 2 plus 2 pi by 2. Okay. So here, this 2 and 2 will be cancelled. Then remaining terms is 4 root 2 into tan 1 by 2 tan inverse 2 root 2. Okay. Now here what we have to do is we have to multiply and divide by 2 in this given expression. Okay. So first let us solve this half portion. When we multiply and divide by 2 here, it will be 4 root 2 tan, then 2 into 1 by 2. See, we have multiplied. Now we have to divide. So let us divide. Tan inverse 2 root 2. Okay, why we are multiplying and dividing by 2? Just to make it in the form of 2 tan inverse x. Okay, so it will be 4 root 2 into tan, and you can see that in the denominator we have 4. Okay, so taking 4 outside. Okay, or it can be written as 1 by 4 into 2 tan inverse 2 root 2. All right. When this 2 will be multiplied with tan inverse 2 root 2, it will be 2 tan inverse 2 root 2. Now we know the formula for 2 tan inverse x. Okay. It is tan inverse 2x upon 1 minus x square. So here 2 tan inverse x is equals to 2 tan inverse 2 root 2. It means that the value of x is 2 root 2. Now what is the formula for 2 tan inverse x? It is tan inverse 2x upon 1 minus x square. All right. So it will be tan inverse, what is 2x? 2 into x. Now what is x here? X is 2 root 2 divided by 1 minus 2 root 2 whole square. All right. So when we will solve this, its value will be equals to 1 by root 2. All right. So now let us write the expression first. In the left part, we have 50 tan into tan inverse 1 by 2, okay, plus pi. And then we have the remaining term. What is the remaining term? 4 root 2. So plus 4 root 2 into. Now we know that the value of this particular expression is 1 by root 2. So in the place of this expression, we have 1 upon root 2. All right. So root 2 and root 2 will be cancelled. Now the remaining terms are 50 tan into tan inverse 1 by 2 plus pi. All right. And plus 4. 4 into 1 is 4. Okay. Now you have to remember a basic formula. Okay. The formula is tan pi plus theta is equals to tan theta. Okay. Here you can see that this expression can be written as 50 into tan pi plus tan inverse 1 by 2 plus 4. Okay. It is in the same form tan pi plus theta. What is the value of theta here? Theta is tan inverse pi by 2. So tan pi plus tan inverse 1 by 2 will be equal to tan of tan inverse 1 by 2, right? Because tan pi plus theta is equal to tan theta. Here theta is tan inverse 1 by 2. So it will be equals to tan theta. What is theta again? Tan inverse 1 by 2. So it will be tan of tan inverse 1 by 2. Here tan and tan inverse will be cancelled. So what will be the remaining term? 1 by 2. So 50 will be multiplied with 1 by 2 and plus 4 is remaining. So 50 into 1 by 2 is 25. 25 plus 4 is 29. So for this question, the correct answer is 29. I hope you are clear with this question. All you have to remember here is the basic formulas related to trigonometry. All right. So for this question, the correct answer is 29. I hope you are clear with this question. Next question is, let C and K belongs to R if f of x is equal to c plus 1 into x square plus 1 minus c square into x plus 2k and f of x plus y is equal to f of x plus f of y minus xy for all x and y belongs to R, then the value of mod of 2 into f of 1 plus f of 2 plus f of 3 plus so on up to f of 20 is equal to. In this question also, we have to find the summation of all these values. And it is in mod. It means that the value will be positive. Okay. And two different functions are given here. So let us write both the functions first. F of x is equals to c plus 1 into x square plus 1 minus c square into x plus 2k. Consider it as equation number 1. Another function is f of x plus y is equal to f of x plus f of y minus xy. Consider it as equation number 2. It is given that x and y belongs to R. All right. So the first thing that we have to look here is that f of x is a polynomial function, right? And f of x plus y means the second function is a functional equation. Okay. Why f of x is a polynomial function? Because it is in the form of ax square plus bx plus c. All right. That is the standard form to write a polynomial. That is why f of x is a polynomial function. So we have to put y is equal to 1 by x in equation number 2. All right. So let us substitute this value. If we substitute y is equal to 1 by x, then it becomes f of x plus y is 1 by x, is equal to f of x plus f of y is 1 by x, minus x into y is 1 by x. So it will be minus of 1. Therefore, we have f of x plus 1 by x is equal to f of x plus f of 1 by x minus 1. Okay. Now what we have to do is we have to substitute all the values. Firstly, let us write the value of f of x plus 1 by x. Now how to write the value? We know that if f of x is given, then we can easily find f of x plus 1 by x. All we have to do is we have to write x plus 1 by x in the place of x. Okay. So by looking at the first equation, we can write the value of f of x plus 1 by x. Remember, all we have to do is we have to just write x plus 1 by x in the place of x. Okay. For example, if we have f of x is equal to 3x minus 1. Okay. If we have to find value of f of 2, it means that we have to put 2 in place of x. Okay. So we get 3 into 2 minus 1. That is 6 minus 1, which is 5. Similarly, f of x is given. We have to find f of x plus 1 by x. It means that in the place of x, we will put x plus 1 by x. So it is c plus 1 into x square. In the place of x, we have to put x plus 1 by x and its square plus 1 minus c square into x. Again, in the place of x, we have to put x plus 1 by x plus 2k. Now, I have written the values for left hand side only. Okay. Now, we have to write the right hand side. What is right hand side? It is f of x. Okay. So, let us write the value of f of x. It is already given. F of x is c plus 1 into x square plus 1 minus c square into x plus 2k. Now we have to write the value of f of 1 by x, right? Again, for f of 1 by x, we have to put 1 by x in the place of x, okay? So in the first equation, f of x is given. Here we have to put f of 1 by x, okay? So it is using the same concept that in the place of x, we have to put 1 by x. So it will be c plus 1 into x square. Now x is 1 by x. So 1 by x square plus 1 minus c square into x. What is x? It is 1 by x. Okay. Plus 2k. And at last you can see that here there is minus 1. Okay. One thing is clear that 1 2k and 1 2k will be cancelled. Okay. Now we do not need to solve this whole equation. Okay. We have calculated so much here, but now what we have to do is we have to just focus on the constant part. On the right hand side, you can see that the constant part is 2k minus 1. Okay. Now talking about the left hand side. Okay. Left hand side have the first part c plus 1 into x plus 1 by x whole square. So let us take this part. C plus 1 into x plus 1 by x whole square, right? For the second term here, x plus 1 by x whole square, we have to use a formula which is a plus b whole square. Do you know what is a plus b whole square? It is equals to a square plus b square plus 2ab. So when we apply the same formula for x plus 1 by x whole square, it will be x square plus 1 by x square plus 2ab, 2 into x into 1 by x. So it is equals to x square plus 1 by x square plus 2. All right. So this term can be written as c plus 1 into x square plus 1 by x square plus 2. Right. Now taking this 2 outside. Okay. When we multiply c plus 1 into 2, we get 2 into c plus 1. Okay. And when we multiply c plus 1 into x square plus 1 upon x square, it will be in the form of the variable. But we just want the constant part. Okay. So the constant part is 2c plus 1. On the left hand side, the constant part is 2 into c plus 1. And on the right hand side, the constant part is 2k minus 1. All right. So both these constant parts will be equal. All right. For example, consider an equation ax cube plus 3b is equal to 6x cube minus c. All right. If we have to compare the coefficient of x cube, then a will be equal to 6. Similarly, when we compare the constants here, then 2k minus 1 will be equal to the constant part of the left hand side. What is the constant part of the left hand side? It is 2 into c plus 1. So consider it as equation number 3. Now the next step that we have to do is we have to put x is equal to 0 and y is equal to 0 in equation number 2. What is equation 2? It is a function that is already given in the equation. So let us write the equation first. Equation 2 is f of x plus y is equal to f of x plus f of y minus xy. So if we put x and y is equal to 0, it will be f of 0 plus 0 is 0. is equal to f of x, x is 0, plus f of y, y is also 0, minus x into y. 0 into 0 is 0. So f of 0 will be equal to f of 0 plus f of 0, 2f of 0, right? So from here we can say that the value of f of 0 will be equal to 0, all right? So it is clear that f of 0 is equal to 0. Now what we have to do is we have to put f of 0 in equation first. What is equation first? Let us write it. Equation first is f of x is equal to c plus 1 into x square plus 1 minus c square into x plus 2k. Okay. Now we have to find f of 0. Okay. F of 0 means in the place of x we have to put 0. So this whole term will be 0, c plus 1 into 0 plus 1 minus c square into 0 plus 2k. Okay. So from here we get f of 0 is equal to 2k. Okay. So one value is f of 0 is equal to 0 and another value is f of 0 is equal to 2k. It means that 2k will be equal to 0 since LHS is equal. So RHS will be also equal. So from here we get k is equal to 0. Okay. Now we have the value of k. We can find the value of c by putting it in the equation number third. Okay. So what is equation number third? It is 2 into c plus 1 is equal to 2k minus 1. We know that k is equal to 0, right? So we put k is equal to 0 here to get the value of c. So it is 2 into c plus 1 is equal to 2 into k. K is 0, so 2 into 0 will be 0 and minus 1. So c plus 1 will be equals to minus 1 by 2. This 2 is in multiplication. When it will go to the right hand side, it will be in the divide form. All right. So c will be equals to minus 1 by 2 minus 1. So it is equals to minus of 3 by 2. All right. So we have the value of c and we have the value of k. Okay. It means we can find the value of exact function which is f of x. Okay. What is f of x? F of x is equals to c plus 1 into x square plus 1 minus c square into x plus 2k. Okay, we have the value of k. K is equal to 0 and we have calculated the value of c now, which is minus 3 by 2. So what we have to do is we have to put the value of k and c to get the exact value of the function. Okay, I hope you are clear with this concept. If we have the value of c and k, then we can get the exact value of this function. So putting c and k here. What is c? C is minus 3 by 2 plus 1 into x square plus 1 minus c square. C square will be 3 by 2 square. So it is 9 by 4 into x plus 2k. K is 0. So 2 into 0. Okay. So this is the value of f of x. F of x will be equal to minus 3 by 2 plus 1. Minus 3 by 2 plus 1 is minus 1 by 2. Okay. So minus 1 by 2 into x square plus 1 minus 9 by 4 into x. So it is minus of 5x upon 4. Okay. So here you can see that it will be minus of x square upon 2 minus 5x upon 4. So it will be equals to minus of 1 by 4 into 5x plus 2x square. What we have done is we have taken 1 by 4 common. All right. So the remaining terms will be 5x plus 2x square. So this is the exact value of f of x. Okay. F of x is equal to minus 1 by 4 into 5x plus 2x square. Now, for this question, we have to calculate the value of summation. Okay. So let us have a look towards it. We have to calculate the value for mode of 2 into f of 1 plus f of 2 plus f of 3 so on up to f of 20. It is forming a summation. So it can be written as mod of 2 into summation of x is equal to 1 to 20 f of x. All right. This 2 is a constant, so it will be outside. So the remaining terms are summation of x is equal to 1 to 20 f of x. Okay, because we have to find 2 into f of 1 plus f of 2 plus f of 3 plus so on up to f of 20. It means that there is a summation and the numbers are from 1 to 20. Okay, now what is f of x? We have to put the value of f of x here. We have to f of x is minus 1 by 4 into 5x plus 2x square. This minus 1 by 4 is again a constant. So it will be outside. Then in modulus, we have to write the function. What is function? F of x, but we have to find the summation. Okay. So summation of fx plus summation of 2x square. Again, 5 is a constant. So it will be 2 into minus 1 by 4. 5 will be constant summation of x plus 2 will be constant and summation of x square. You can see that this is a standard series. Okay. Now we have to use two basic formulas here. Okay. For this part, we have to use the formula which is n into n plus 1 divided by 4. And for this part, we have to use a formula which is n into n plus 1 into 2n plus 1 divided by 6. All right. So 2 into minus 1 by 4 is minus of 2 by 4, right? Then 5 into, for summation of x, we have to use the formula n into n plus 1 by 4. What is n? N is 20. 20 is the total number of elements. So 20 into 20 plus 1, it is 21 divided by 4 plus. For second term, it is 2 multiplied by summation of x square. For summation of x square, we have to use this formula, which is n. N is 20. N plus 1 is 21. 2n plus 1 means 2 into 20 plus 1. So it is 41. So into 41 divided by 6. All right. Now let us take this constant inside the modulus. Okay. So it will be mod of 2 by 4 multiplied by 5 into 20 into 21 divided by 4 plus 2 into 20 into 21 into 41 divided by 6. All right. So this will be equals to minus 2 by 4 into, this will be cancelled. 5 into 5 into 21 is 2730. All right. Plus again 2 into 20 into 21 upon 41. Okay. This whole part is 2 into 20 into 21 into 41 divided by 6. All right. So this will be cancelled. 2 ones are 2, 2 threes are 6, 3 ones are 3, 3 sevens are 21. So 20 into 7 into 41 is 5740. All right. So we can see that the value will be negative. But since here there is mode, so the value will be positive. So it becomes minus 1 by 2 into 2730 plus 5740. All right. So the value will be positive because there is mode. So 1 by 2 into 2730 plus 5740 is 3395. So this is the exact value for the summation here. So for this question, the correct answer is 3395. I hope you are clear with this question. Moving on to the next question. Let a hyperbola is x square upon a square minus y square upon b square is equal to 1, where a and b are greater than 0, be a hyperbola such that the sum of lengths of the transverse and conjugate axis is 4 multiplied by 2 root 2 plus root 14. If the eccentricity of the hyperbola is under root 11 upon 2, then the value of a square plus b square is equal to. So for this question, we have to find the value for a square plus b square. Firstly, let us consider all the formulas that we have to use for this question. Okay. Here in this question, the value of eccentricity is given. So firstly, let us write the basic formula to calculate the eccentricity, right? Eccentricity is always denoted as E. And the basic formula is E square is equal to 1 plus B square upon A square. Another thing that is given in the question is sum of length of the transverse axis and the conjugate axis. So what is the formula for length of transverse axis? Length of transverse axis is equals to 2a, and length of conjugate axis is equals to 2b. So you have to remember this basic formulas to solve this question. All right. Now, let us come to the solution of this question. A hyperbola is given here, which is x square upon a square minus y square upon b square is equal to 1. Okay. And the eccentricity is given here, which is under root 11 by 2. It means that E is equal to under root 11 by 2. Okay. So let us substitute the value of E in the formula for eccentricity. All right. The formula is E square is equal to 1 plus B square upon A square. Okay. If E is under root 11 by 2, then E square will be 11 upon 4. So this is equal to 1 plus B square upon A square, right? So from here we can get the value of B square. Okay. 11 by 4 will be equal to A square plus B square upon A square. Now on cross multiplying, we get 11a square is equal to 4a square plus 4b square, right? So it will be 11a square minus 4a square is equal to 4b square. 11 minus 4 is 7. So 7a square is equal to 4b square. So we have formed a relation here. From here we can get the value of b square. B square will be equal to 7a square upon 4. All right. When this 4 will go to the left hand side, it will be in the divide form. So now we have the value for b square. Okay. Let us find the value of b here. If b square is 7a square upon 4, then b will be equals to under root of 7a square upon 4, right? So b will be equals to under root of 7 into a by 2. This is the value of b. Okay. Now let us do one thing. Substitute this value of b square in the given equation of hyperbola. What is the given equation of hyperbola? X square upon a square minus y square upon b square is equal to 1. We have the value for b square. We have already calculated it now. B square is equal to 7 upon 4 into a square. So substituting this value here in the equation of hyperbola, we get x square upon a square minus y square upon b square. What is the value for b square? 7 by 4 a square. All right. This is equals to 1. Okay. Now we have to see that in the question it is given sum of the length of transverse and the conjugate axis is 4 into 2 root 2 plus root 14. Okay. It means that we have to do the sum of length of transverse axis and conjugate axis. So what is length of transverse axis? It is 2a. And what is length of conjugate axis? It is 2b. Okay. So let us write sum of length of transverse axis and conjugate axis will be. We know that length of transverse axis is 2a and length of conjugate axis is 2b. All right. So now we have to substitute the value for b here. And it is also given that sum is equal to 4 into 2 root 2 plus root 14. Okay. So this sum is equals to 4 into 2 root 2 plus under root of 14. All right. So now put the value of b in left hand side, that is LHS. Okay. So it will be 2a plus 2b. What is the value of b? B is root 7a upon 2. We have already calculated it. So 2 and 2 will be cancelled. Okay. So this is equal to 4 into 2 root 2 plus root 14. This is the value that is already given in the question, right? So the equation becomes 2a plus under root 7a is equal to 4 into 2 root 2 plus under root of 14. Okay. Now you can see that in this term, root 2 is common. Okay. So if we take root 2 common from here, the left hand side is 2a plus under root of 7a. Okay. And right hand side is 4 multiplied by. When we take root 2 common from these two terms, then the remaining terms will be 2 plus root 7, right? And if we take a common from the left hand side, you can see that a is common in both these terms. So if we take a common, the remaining terms are 2 plus root 7. It is equal to 4 into root 2. 4 root 2 multiplied by 2 plus under root of 7. Now you can see that 2 plus under root of 7 and 2 plus under root of 7 will be cancelled. So the value of a will be 4 root 2. All right. We have the value of a. We have the value of b. What is the value of b? B is under root of 7a upon 2. But For this question, we have to calculate the sum for a square plus b square, right? If a is 4 root 2, a square will be 4 root 2 into 4 root 2, right? So it will be equals to 4 into 4 is 16. 16 into 2 will be 32. So the value of a square is 32. Now calculating b square. B square will be root 7 upon 2a into root 7 upon 2a. Okay. So what will be the value of b square? It will be 7 by 4a square. Okay. And we know that we have the value for a square. What is a square? A square is 32. Okay. So b square will be equal to 7 by 4 into 32. 4 and 32 will be cancelled. 7 into 8 is 56. So the value of b square is 56, right? Now we have to add both these values. A square is 32 plus b square is 56. 32 plus 56 is 88. So the value for a square plus b square is 88. So for this question, the correct answer is 88. I hope you are clear with this question. The main basic formulas that we have used here is the formulas for eccentricity, formula for length of transverse axis, and the formula for length of conjugate axis. I hope you are clear with this question. Next question is, let P1 such that R vector dot product 2i plus j minus 3k is equal to 4 be a plane. Let P2 be another plane which passes through the points 2 minus 3 2, 2 minus 2 minus 3 and 1 minus 4 2. If the direction ratios of the line of intersection of P1 and P2 be 16 alpha and beta, then the value of alpha plus beta is equal to. So this equation basically gives us information about two different planes. First plane is P1, okay, and it has an equation that is R vector into 2i plus j minus 3k. And the second plane does not have an equation here. It means that we have to find the equation for second plane. But in the question, it is given that second plane P2 passes through three different points, right? So these are the three different points. And it is also given that if the direction ratios of the line of intersection of both these planes are 16 alpha and beta, then the value of alpha plus beta is equal to, okay? Firstly, let us write the first plane. P1 is given as R vector dot product 2i plus j minus 3k, all right? So this is not the equation that is in the Cartesian form, okay? So we have to convert this equation into Cartesian equation, okay? So we know that R vector is equal to xi cap plus yj cap plus zk cap. This is the basic equation for R vector, okay? So substituting here, P1 will be xi cap plus yj cap plus zk cap dot product 2i plus j minus 3k cap, all right? Now we have to find the dot product of both these given vectors, right? So this will be equals to x into 2 is 2x plus y into 1. What is the coefficient of j here? 1. So it will be y plus z into minus 3. It will be minus 3z. So now this is the Cartesian equation for plane P1, all right? Now you can see that for P2, three different points are given. So P2 passes through 3 points and the points are 2 minus 3 2, 2 minus 2 minus 3 and 1 minus 4 and 2, all right? So consider this as x1, y1, z1, x2, y2, z2 and x3, y3 and z3, all right? Now we have to find the equation for the plane P2, okay? So how do we find the equation for a plane in which different points are given? If a plane passes through different points, then the basic formula to find the equation is in the determinant form. Here the plane is P2, so it will be equals to determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1. Then x3 minus x2, y3 minus y2 and z3 minus z2. This is the basic concept to find the equation of a plane which passes through three different points. Okay, and this will be equals to 0. So now let us find the value for this determinant. It will be x minus x1. What is the value of x1? It is 2. Y minus y1. The value of y1 is minus 3. So minus minus will be plus. Z minus z1. Z minus. What is the value of z1? It is 2. Next row will be x2 minus x1. What is x2 here? It is 2. So 2 minus x1. x1 is 2. Y2 minus y1. Value of y2 is minus 2. And value of y1 is minus 3. So minus 2 minus minus 3. It is minus 2 plus 3. So it will be equals to 1. Right? Next will be z2 minus z1. What is the value of z2? It is minus 3. And z1 is 2. So minus 3 minus 2 is minus 5. Next is x3 minus x2. x3 is 1. x2 is 2. Okay, so 1 minus 2 will be minus of 1. Then y3 minus y2. y3 is minus 4 and y2 is minus 2. So minus 4 minus minus 2. It will be minus 4 plus 2, which is equals to minus of 2, right? Again, this value is y3 minus y2. Okay, what is y3? y3 is minus 4 and y2 is minus 2. So minus 4 minus minus 2. All right. So this will be equals to minus 4 plus 2, which is equal to minus of 2, right? Then z3 minus z2. What is the value of z3? z3 is 2 and z2 is minus 3. So 2 minus minus 3. It will be 2 plus 3. Okay. So it will be equals to 5. Right? Now this is equal to 0. We have to calculate the value of the given determinant here. Okay. How to expand this determinant? Firstly, we have to write the first term. What is the first term? X minus 2. Now we have to eliminate first row and first column. All right. So after eliminating first row and first column, the remaining numbers are 1, minus 5, minus 2 and 5. Then with a negative sign, we write the second term. What is the second term? Y plus 3. Now we have to eliminate first row and second column. All right. So the remaining numbers are 2 minus 2 is 0, minus 1, minus 5 and 5. All right. Then with a positive sign, we write the third term. Third term is z minus 2. And now we have to eliminate first row and third column. So the remaining numbers will be 0, 1, minus 1 and minus 2. All right. So this will be equals to x minus 2 into. Now we have to cross multiply. 1 into 5 is 5 minus. Minus 5 into minus 2 is plus 10. But we have to subtract 1 into 5 minus 2 into minus 5. So it will be 10 minus y plus 3. Okay. This will be multiplied with 0 into 5 is 0 minus 1 into minus 5 is 5 plus z minus 2. This will be multiplied with 0 into minus 2 is 0 minus 1 into minus 1 is minus 1. All right. So this will be x minus 2 into 5 minus 10 is minus 5 minus y plus 3 into minus 5 plus z minus 2 into 0 minus minus 1 is plus 1. All right. So it will be equals to x into minus 5 is minus 5x. Then minus 2 into minus 5 is plus 10. Then y into minus 5 is minus 5y. But here there is a negative sign, so it will be plus 5y. 3 into minus 5 is minus 15. But again, with a negative sign, it will be plus 15. Then plus z minus 2. Okay. So it will be equals to minus 5x plus 5y plus z. Okay. These are the variables. Now what are the remaining numbers? Remaining numbers are 10 plus 15 minus 2. 10 plus 15 is 25. 25 minus 2 is 23. So this is equal to 0. It can be also written as minus 5x plus 5y plus z is equal to minus 23. So this is the required equation for second plane, which is P2. Okay. So this is the equation for P2. Now we have two equations. First equation is for plane P1 and the first equation is 2x plus y minus 3z. All right. And this is equal to 4. Okay. because it is already given in the question that it is equal to 4, right? So let this be equation number 1. And this is the equation for plane P1. For plane P2, the equation is minus 5x plus 5y plus z is equal to minus 23. Consider this as equation 2. Okay. We have two different equations. All right. And it is given that 16 alpha and beta are the direction ratios of the line of intersection. Okay. So for the direction ratios, we have to use both these equations, and simply after cross multiplying by using both this equation, we get x upon 1 plus 15 is equals to minus of y upon 2 minus 15 is equal to z upon 10 plus 5. Okay, this is the value that we get after cross multiplying by using both these equations. Okay, now let this be equal to lambda. Okay, each and every term is equal to lambda. So separately equating this term, we get x upon 1 plus 15 is equal to lambda. Okay, so x upon 16 will be equals to lambda. So what will be the value of x? X will be 16 into lambda, right? Similarly, minus y upon 2 minus 15 is equal to lambda. So minus y will be equal to 2 lambda minus 15 lambda. Okay. So minus y will be equals to 2 lambda minus 15 lambda. What is 2 lambda minus 15 lambda? It is minus 13 lambda. So y will be equals to 13 lambda. Similarly, equating the last term. What is the last term here? Z upon 10 plus 5. It is equal to lambda. So z will be equals to 10 lambda plus 5 lambda. It will be cross multiplied on the right hand side. Okay. So z will be equals to 15 lambda. Now we have the value for x, y, and z. Okay. In the question, it is given that 16 alpha and beta are the direction ratios of line of intersection. They are the direction ratios. It means that 16 is equals to x, alpha is equal to y, and beta is equal to z. Okay, we have the value for x. What is x? X is 16 lambda. So 16 lambda will be equal to 16. Okay. So lambda will be equals to 1. Now, if we have the value of lambda, then we can easily get the value of y and z. Okay. What is y? Y is equal to alpha. So first let us calculate y. Y is 13 into lambda. Lambda is 1. So y will be 13 into 1. So y is 13. But we know that y is equal to alpha. Therefore, alpha is equal to 13. Similarly, let us calculate the value of z. Z is 15 lambda, right? 15 lambda means 15 into lambda. The value of lambda is 1. So z will be 15. What is z? Z is equals to beta. So beta will be 15. Okay. Now we have the value for alpha and beta. In this question, we have to find the value for alpha plus beta. What is alpha? Alpha is 13 plus what is beta? Beta is 15. Okay. So 13 plus 15 is equals to 28. So the sum of alpha and beta is 28. So for this question, the correct answer is 28. I hope you are clear with this question. The basic concept here is for the direction ratios of the line of intersection. All right. And there is one more formula that we have used here is if a plane passes through 3 different points, then there is a basic formula to find the equation of that plane. Okay. It is in the form of determinant. So for this question, the correct answer is 28. I hope you are clear with this question. Now comes the last question of this paper. And the question is let B1, B2, B3 and B4 be a 4-element permutation with Bi belongs to 1, 2, 3 and so on up to 100. For I lies between 1 and 4 and Bi is not equal to Bj. For I is not equal to j such that either B1, B2, B3 are consecutive integers or B2, B3, B4 are consecutive integers. Then the number of such permutations B1, B2, B3 and B4 is equal to. Okay. So for this question, we have to find the number of total permutations for B1, B2, B3 and B4. And it is given that it is a 4-element permutation. Okay. The 4 elements are B1, B2, B3 and B4. Also, Bi belongs to 1, 2, 3, so on up to 100. Now, what are these numbers? These are the values for B1, B2, B3, and so on up to B100. All right. And two different conditions are given here. First condition is either B1, B2, B3 are consecutive integers. And second condition is either B2, B3, B4 are consecutive integer. So what do you understand by consecutive integers here? In simple words, consecutive integers are the integers that follow each other in order. Okay. Either they will have a difference of 1 between them, or they will have a increase of 2 between them. All right. So basically they have a difference of 1 between every two integers. All right. So we have to form two different sets here. First set will be the set where B1, B2 and B3 are consecutive integers. And second set will be the set where B2, B3 and B4 are consecutive integers. Okay. So let us suppose A be the set when B1, B2 and B3 are consecutive. And let B be the set when B2, B3 and B4 are consecutive. All right. Now, talking about set A. Set A is the set when B1, B2 and B3 are consecutive. Okay. So if we take the same elements which are present in the set 1, 2, 3 to 100, then how we can write the numbers that are consecutive? See, the possible ways of writing consecutive numbers is 1, 2, 3, then 2, 3, 4, so on up to 98, 99 and 100. Okay, we have taken the same set which is given in the question. Okay, you can see that here there is a difference of 1 between two numbers. So this is the consecutive numbers. All right. So here total how many such sets can be formed? Total 98 set can be formed if we start from 1 and we go up to 100. Okay. And in how many ways we can write these numbers? We can write this in 97 ways. All right. So the probability of A will be 97 plus 97 plus 97 up to 97 times, because we can write this set of elements in 97 ways. And the total sets are 98. So it will be divided by 98. Okay. So its probability will be 97 into 98. All right. Similarly, we have to consider set B. Okay. Set B is the set when B2, B3 and B4 are consecutive. So for set B also, the probability will be same, which is 97 into 98, because the total consecutive numbers between 1 to 100, if we take three numbers one at a time, then the total sets will be 98 and we can write them in 97 possible ways. All right. So n of B will be also 97 into 98. Now let us look at the question. We have to find the number of permutations for B1, B2, B3 and B4. Okay. But you can see that A is the set which contains B1, B2, B3 and B is the set which contains B2, B3 and B4. So firstly, we need to take the intersection of both these sets. Okay. So n of A intersection B will be 97, right? Because in both the sets, we can have 97 possible ways. Okay. Now talking about the union. We need a union of all these elements, because in set A, B4 is not present and in set B, B1 is not present. Okay, so what will be n of A union B? N of A union B means B1, B2, B3 union B2, B3 and B4. We know that in union, no digit is repeated. So it will be equals to B1, B2, B3 and B4. We have to calculate this value. It means that we have to calculate n of A union B. There is a very basic formula to calculate it. Do you know what is the basic formula? In the set, the basic formula is n of A union B is equal to n of A plus n of B minus n of A intersection B. This is the very basic formula in the set theory. Okay. Now what we have to do is we have to substitute all the values. We have n of A, n of B and n of A intersection B. All right. So n of A union B, which is the total permutations for B1, B2, B3 and B4. It will be equals to n of A. What is the value of n of A? It is 97 into 98 plus n of B. N of B is also 97 into 98 minus n of A intersection B. What is the value of n of A intersection B? It is 97. Okay. So here n of A union B, we have to calculate its final value, right? So what is 97 into 98? 97 into 98 is 9,506 plus again 97 into 98, 9,506 minus 97. So n of A union B will be equals to 9506 plus 9506 is 19,012 minus 97. So this is equals to 18,915. So this is the value of n of A union B. What is n of A union B again? It is B1, B2, B3 and B4. Okay. So for this question, the correct answer is 18,950. I hope you are clear with this question. The basic thing to remember here is how to form the set of consecutive integers. All right. Consecutive numbers have a difference of 1 between them. And in this question, we were given two different sets. All right. A contains B1, B2, B3 as consecutive numbers and B contains B2, B3, B4 as consecutive numbers. That is why we have taken the intersection. And finally, we found out the value for the number of permutations for B1, B2, B3 and B4. All right. I hope you are clear with this question and I hope you understood all the questions very carefully. Keep learning more and keep scoring high.